Here we're going to look at using the sum and difference identities to rewrite an expression. But what's special about this example is that I'm giving you the back end of the identity part. In other words, I'm giving you the expanded view, and I'm asking you to use the expanded view idea to figure out your triangle and then be able to condense it back down to actually evaluate the result. So the way that we have to do this is, the first thing we need to do is we need to look at the expanded result we have and identify the identity we're working with. So here I've got the cosine of pi over 12, 5 pi over 12, and the cosine of 2 pi over 3, plus the sine of 5 pi over 12, the sine of 2 pi over 3. So this is the cosine identity, and because I have the plus right here, this automatically tells me that I am using the cosine of u minus v, which comes out to be the cosine of u, cosine of v, plus the sine of u, the sine of v. So once you identify which trig function or which identity you're using, based on this expanded part, we identified the identity, we can also identify the u and v. So here, what I had is the cosine of 5 pi over 12. So this automatically tells me that u is going to be 5 pi over 12, which means v is going to be 2 pi over 3. So now, with that, one of the things that I want to do right away is I have to work with this condensed version, because I'm taking the expanded piece down into the condensed piece, and then from there figuring out what the evaluation is going to be. So I'm going to plug these in, so I know that this is going to be the cosine of 5 pi over 12 minus 2 pi over 3. So what I have to be able to do is I have to actually do this math here. So I need to have the least common denominator, which in this case is going to be 12. So this 5 pi over 12 doesn't have to change. So this is 5 pi over 12, still minus. In order to turn 3 into 12, I multiply by 4. So this becomes 8 pi over 12. And so here, this is going to reduce down. 5 minus 8 is going to give me a negative 3 pi over 12, which again can reduce further, which is going to give me negative pi over 4. So you had to do a little bit of internal math in order to keep going. So what we have here is we actually have the cosine of negative pi over 4. So we need to kind of do a little bit of looking here. So first and foremost, what are some things that we know? So as an aside, so we know that pi over 4 is equal to 45 degrees. Therefore, it makes sense that negative pi over 4 has to be negative 45 degrees. So if we take a look at our unit circle here, pi over 4 is this positive in this first quadrant. This is the positive 45 degrees. But negative says I would start at 0 and I would move down. So my negative pi over 4 is going to lie right here, which is at this 315 degrees. Okay? So my negative is going to come along here, and it's going to be the triangle that looks like that. So I want to draw that reference triangle. So here I would go ahead and draw it. So we are dealing with my reference triangle. So it's going to come straight out here and it's going to come down. So here we go. This is my negative pi over 4. And so here what I know is that pi over 4 is that 45. And so my radius is 1. This is a positive x, so this is the square root of 2 over 2. This is a negative y, so negative square root of 2 over 2. Now the reason this is important is because when we evaluate here, we have to take the sign into account. So here, the cosine says that we are doing, so here's my pi over 4, and so your cosine is still going to be adjacent over your hypotenuse, but we have to take the negative angle into account. And so here we're going to end up having that this is going to give you your adjacent over hypotenuse. So you've got your negative here, so we've got the square root of 2 over your hypotenuse being 1. And so with that being the case, you're going to come up with the square root of 2 over 2. And so drawing your triangles are going to be incredibly important because they're going to help you make sure that you are using your appropriate information. Okay. Alright, let's look at another one here. So here I have the tangent of 5 pi over 12 plus the tangent of 3 pi over 4. And this is over 1 minus the tangent of 5 pi over 12 and the tangent of 3 pi over 4. And so here, once again, we have to first write down the identity that you have. And so in this case, I have positive on top, negative on the bottom, which says I am doing the tangent of u plus v is equal to the tangent of u plus the tangent of v all over 1 minus the tangent of u, the tangent of v. So this tells us again right away that we are dealing with u being 5 pi over 12 and v being 3 pi over 4. Now just like before, the first thing we need to do is we need to put it together. So this is going to become the tangent of 5 pi over 12 plus 3 pi over 4. Now with this, we have to, just like we did before, add them together. So right in here, we're going to do a little bit of work. Again, we need a least common denominator, which is going to be 12. So this is going to be 5 pi over 12 plus, to turn 4 into 12 says we multiply by 3. So this is 9 pi over 12. When we add that together, we have 5 plus 9. So this is going to give you 14 pi over 12. We need to reduce these, so we can divide each by 2, and so we end up with 7 pi over 6. So here what we actually have to work with is we have the tangent of 7 pi over 6 is our stuff. And so here again, we can use the idea of our unit circle. So if you look around, notice I actually have 7 pi over 6. It's over here at 210 degrees. And so I'm going to go ahead and draw this triangle right here. It's in quadrant 3, which means both of my x and y's are going to be negative. Now notice, because this is 210 degrees, we are dealing with that 30, 60, 90 triangle. And since this is the smaller side, it means that this angle right here is actually the 30 degrees. And so here we're going to go ahead and we're going to draw that. So we've got, let me switch colors here. So we've got our coordinate. We're going to draw this triangle in right here. Here's our theta. So we know this is 7 pi over 6, which is the same as 30 degrees, okay, in terms of its reference. And so here we know that my x term here is going to be negative square root of 3 over 2. My radius is 1, and my y value is negative 1/2. So here I've got the tangent. And so if I look at it, remember your tangent is always going to be opposite over adjacent. So this is going to be negative 1/2 divided by negative square root 3 over 2. My fractions say, because both denominators are 2, this is going to be the same as 1 over the square root of 3. However, I need to rationalize, so this gives me the square root of 3 over 3. So those are 2 examples of giving you the expanded view and asking you to condense it down and solve for the result. So if you have any questions, please let me know. If you feel like you need to see an additional example, let me know that too, and I would be more than happy to go ahead and work that out for you. Otherwise, I do hope you enjoyed it as much as I did, and I look forward to seeing you next time.